This video is to help us learn to recognize the role of sample size in a probability distribution. Super important. According to the World Almanac, approximately 25% of all babies born in Texas are Hispanic. So we're going to consider a city in Texas with 2 hospitals. Suppose that hospital A has 10 births per day and hospital B has 50 births per day. Now, a very important piece of information that they're giving us is that 25% of all babies born in Texas, this is 1999, are Hispanic. So that is, if we took all the births in Texas, we're going to figure 25% of them are going to be Hispanic. So we're going to use technology here. I'm going to use an applet to simulate the births for 365 days at these 2 hospitals and calculate the proportion of Hispanics born per day at each hospital. So let's take a look at a piece of at how we're going to do that on a simulation. So this simulation isn't exactly for Hispanic births in Texas. It's actually called the Reese's Pieces simulation, but it works about the same. We have a process here, and we have a probability of orange. Well, we're going to change that to the probability of Hispanic, and we're going to make that 0.25. Let's make it 0.25 so we can see it better. 0.25. And the number of births in this hospital, that is the number of candies I'm going to pull out of the bowl, or the number of births in hospital A is 10. And the number of samples, we're going to do this 365 times, 1 for each day of the year. Look, 365. We're not going to show any animation, and I want my thing to show the proportion of orange, the proportion of Hispanic. So let's draw the samples here. And this is our distribution. It's kind of like a histogram, not exactly like a histogram. This is our distribution of the number of Hispanic babies born over the course of that year. So we can see that there was, maybe about 25 of those births had 0 Hispanic babies. About 60% of those births, 60 of those births had 10% Hispanic. A little, maybe close to 100 had 20% Hispanic. And remember, 25 is what the average is for the state of Texas. In this hospital A, looks like maybe about 90 of them had 30% Hispanic. 90 of the days had her 30% Hispanic. You know, way out here, only a handful of days had 60% babies that were born Hispanic. So let's we're going to copy that over to a smartboard page. Now let's do the same thing for hospital B. Now the process here, the probability of orange, or the probability of Hispanic, is still 0.25, which is the percentage in the state of Texas. But if for hospital B, instead of 10 babies being born per day, there are 50 babies being born per day. And the number of samples is still 365. We have 365 days in the year. Now, I'm going to click this little box right here that says Show Previous Results. So the previous results from this is the one well, let me just let me draw the samples here, and we'll show you what it looks like. So I'm going to draw the samples, and I'm going to show the previous results. That'll be important to look at later. Okay. So we can see here now. I'm going to actually get rid of that for a second. It doesn't look like there were any days on which 0% were born Hispanic. Every day seemed to have some. So like about 18% or 0.18 proportion looked like there are about 20 days that had about 18% Hispanic. And I'm going over here to, well, it looks like this is 20, 22, 24, 26. So 0.26 close to 50 days, but you can kind of see that right in here, right around 25 is clearly the most, and we don't have any that are like at 60% days, and we have none that are 0% days. So if I kind of look at the previous results, you can see that those were a lot more spread out. They're these lighter gray ones. When we had 10 babies being born per day, the variability was quite a bit more than with 50 babies born per day. So let's take a snip of that and put that also on the smartboard. So one of the things I can see looking at these one on top of the other, it's a little bit tricky here because the Y scales are different. The Y scale here goes up to 180. The Y scale here only goes up to 50. But the more important thing is that I can see that Hospital A, this is Hospital A, which had 10 births per day, and this is Hospital B, which had 50 births per day. So here's the 10, and here's the 50. Hospital A has a much broader range. It goes from 0 all the way up to 60%. And whereas Hospital B, which has 50 births per day, doesn't have, the lowest one is 6%, and it doesn't go anywhere near 60%. It gets maybe up about as high as 40%. So let's kind of look at the questions that they're asking us. Which hospital has more days on which more than 40% of the babies are born Hispanic? Well, let's take a look at our picture. Here is 40% Hispanic right here, and I got that bar right there, and that bar there, and that bar there. So I have a decent chunk of babies in Hospital A, decent number of days where I had more than 40% born Hispanic. Hospital B, I have hardly any, maybe that one little one right there, not very much. So the answer to that question is clearly Hospital A has more days on which more than 40% of the babies are born Hispanic. The next question is asking, which hospital has more days on which between 15 and 35% of the babies are born Hispanic? Now let's remember, on average in the state of Texas, 25% of the babies are born Hispanic. That's right in the middle of 15 and 35. Let's go back and look at our pictures. Well, 15 to 35%, that would be like right about here to right about there. So this many of the total were in Hospital A. But if I go 15, which is right about here, sorry, it's not straight. Let me make it straight. Try to make it straight. 15 to 35. Oh, I can see a lot larger percentage of the births in Hospital B. The days in Hospital B had between 15 and 35%. So notice, the state of Texas, the average is 25%. This is a larger sample size here. We have 50 births per day as opposed to 10 births per day. Well, the larger sample size seems to be producing more closer to the average in the actual population of the state of Texas. The larger the sample size, the less the variability. The smaller the sample size, the more variability. Let's look at the next question. Which hospital has more days on which less than 40% of the babies born are Hispanic? Now remember, 40% is pretty high above the Texas average of 25%. So let's go over to the app and take a look and see what that shows us. So here is Hospital A with 10 babies born per day. I'm going to draw my samples here. And then there's a nice little feature here where I say less than or equal to 0.4. and I'm going to count them, and I can see that 94%, 95% of the days had less than 40%, 40% or less of the babies born Hispanic. 95%. Let's take a look at it with hospital B, 50. And I'm going to draw the samples here. So draw the samples. Wow, hospital B, almost 100%, 99.73% of the days had less than 40% of the babies born Hispanic. That's because, again, the larger the sample size, the closer it's going to be to the Texas average of 25%. So it's very unusual to get a baby that to get a day when more than 40% of the babies are Hispanic. So the larger the sample size is going to produce much fewer of those kind of days. Let's just take a look at it in one other way. I'm going to get rid of that. And I'm going to draw the samples for, I'm going to reset, and I'm going to redraw the samples for hospital B, which is the 50 babies. And I want to show the summary statistics. So I'm going to draw the samples, and I can see that on average, 25% of the babies were born Hispanic, with a standard deviation, our spread, of 0.061. Well, let's look at hospital A. Only 10 babies born per day. Draw the samples. Well, we still have, on average, 25% of the babies are Hispanic. But our standard deviation, instead of being 0.06, is much larger at 0.142. So I have more variability with a smaller sample size. So the last question says, explain how you could have answered these questions, part B, C, and D, without the benefit of the simulation. And the answer is, and this is really where you need to kind of think and understand, is larger the sample size, less variability, the closer it's going to be to the actual population average. The smaller sample size, much more variability. So if you think about it that way, you can answer a lot of these questions without even having to do any simulation or calculation.